Welcome, ladies and gentlemen. So what I'd like to do is show you how to find all of the zeros when we are given two irrational zeros. And you can see we have two irrational zeros, and we have the conjugate of them. We have the positive and the negative. And we want to be able to find, though, the remainder of these irrational zeros of this polynomial. Now, before we know, once we have a zero, we can use synthetic division. However, remember, when we're finding the zeros, the main important thing is we're finding the zeros when f of x is equal to 0. So the first thing I would always look at is see, can you factor something out to kind of make the problem simpler, to more simple. So if I factor out an x, then that is going to help me out a lot when doing this. So if I was going to set them both equal to 0, I would still need to further factor this down so I can find the factors. Well, if this is a factor of the polynomial, it's still going to be a factor of this polynomial here. So therefore, all I'm simply going to do is now use this as my polynomial, because I already know 1, 0 is x. So now I'm going to further use synthetic division to further factor this down. So I'll choose my 1, 0, 1 plus the square root of 5. And then I'll use the coefficients of this factor down polynomial, which is going to be 1, -3, -2, and +1. So again, remember synthetic division, you bring down the 1. Now we have to multiply 1 times 1 plus square root of 5. Well, applying distributive property here, 1 times 1 is 1. 1 times square root of 5 is the square root of 5. However, now I'm adding a real number to an irrational number. Well, I can only add the rational numbers. -3 plus 1 is -2 plus the square root of 5. Now I need to multiply -2 plus square root of 5 times 1 plus the square root of 5. So I'm just going to do this to the side to make sure I'm doing my math correctly. And again, you're just going to want to follow FOIL here. So -2 times 1 is a -2 times -2 square root of 5 plus the square root of 5 plus square root of 5 times square root of 5 is 5. -2 square root of 5 plus the square root of 5, you add the coefficients, which is in this case is going to be a -1. And -2 plus 5 is going to be 3. So I have 3 minus the square root of 5. So I have 3 minus the square root of 5. Now, when I combine my real numbers, I get 1 minus the square root of 5. Again, now I need to multiply these two. What's nice about this one when multiplying them is hopefully you understand and see that this is now going to produce the difference of two squares. The first two terms are the same. The last two terms are the same, addition and subtraction. So therefore, I only need to multiply the first and last two terms, which gives me 1 minus 5, which equals -4. Uh-oh. Did I work on that? Oh, that was a 4x. I didn't write the problem correctly. I was wondering. I was like, uh-oh. OK. So when you factor that out, you're left with a 4. Sorry about that. I didn't write the problem right. So therefore, this should be a 4. So that gives you a -4, which is 0. So therefore, again, this proves that I did my synthetic division correctly. Remember, anytime you do, if you know it's a 0 and you do synthetic division, you get a remainder, you did something wrong. So now I need to further divide this, though, because this as a factors, these as the coefficients of my factor are really not going to help me much. So I can further divide this as 1 minus the square root of 5. And therefore, again, now take these points. So -2 plus the square root of 5, 1 minus the square root of 5. Now I bring down the 1. 1 times 1 negative square root of 5 is going to be 1 negative square root of 5. The square root of 5 and minus negative square root of 5 gives me 0 square root of 5, which is just 0. -2 plus 1 is a -1. -1 times +1 is a -1. -1 times negative square root of 5 is a positive square root of 5. That goes to 0. So therefore, that's my remainder. That's my constant, which is x to the 0, and that's my linear. So therefore, I have x minus 1 is going to be my other factor. Right? Well, remember, if that's your other factor, to find the 0, you just set it equal to 0 and solve. X equals 1. So therefore, if I know my zeros, I was given these two as zeros. And then I found this, my x minus 1 is my other factor, and 1. So my zeros are 1, 1 plus the square root of 5, and 1 minus the square root of 5. Now, one thing I want you to pay attention to is, oops, I'm sorry, and I forgot at the beginning, I originally factored out that x, right? So that x, if I was going to apply zero product property, that x would equal 0. So 0 is also a factor. And the other reason why you can know about that is how many zeros do I have? 1, 2, 3, 4. Remember, by using the fundamental theorem of algebra, if my original polynomial has a degree of 4, we know there's going to be 4 zeros. So that's another way to kind of check your work. Now, there is another way, though, that we can do a problem like this. Rather, when we know where we have our zeros, we also know that we can multiply, we can rewrite those zeros as factors. Because remember, if I said x equals 3 is a 0, to write it as a factor, I can write it as x minus 3. Or write x minus 3 equal to 0, so therefore x minus 3 is my factor, right? So therefore, I can do that with both of these irrational zeros. If I know both 0, all of my zeros I can write equal to 5 because they're the solutions that make the function equal to 0. Then I solve for them for 0. So it's x minus 1 minus square root of 5 equals 0. X minus 1 plus the square root of 5 equals 0. Then I can write those as the product of factors. So x minus 1 minus square root of 5 times x minus 1 plus the square root of 5. And then I can multiply these out. Now, you can multiply them out by using synthetic division. He doesn't really like me much. So you can multiply them out by using synthetic division. Or you can group the first two terms, noticing that these are the same and your square roots of 5 are the same. So therefore, looking at the pattern here, you can see I'm really multiplying a minus b times a plus b, which is a difference of 2 squares. So that tells me when I multiply this, I have x minus 1. When applying the difference of 2 squares, remember a minus b times a plus b produces the product of a squared minus b squared. So that's x minus 1 squared minus negative square root of 5 times positive square root of 5 is going to be a negative square root of 5, or negative square root of 5 squared, which is just minus 5. Then I can multiply out, I can expand, my x minus 1 squared, which would be x minus 1 times x minus 1. Expanded gives me x squared minus 2x plus 1 minus 5. And therefore, it gave me x squared minus 2x minus 4. So by multiplying my zeros, rewriting them as factors and multiplying out, I now produce another factor. And if I know what one factor is, I can use that factor. I can use division to find the other factors. Now, we use division, synthetic division here. But when you have a factor that's to a power larger than 1, you have to use long division. So again, this is like the other way to do the problem without doing synthetic division. So therefore, I can use synthetic division here. So x squared minus 2x minus 4 is going to evenly divide into my original polynomial. Actually, we can just evenly divide it into this one. Actually, let's go back up to our original polynomial, because we don't really, minus 3x cubed minus 2x squared plus 4x. All right, so x squared goes into x to the 4th. X squared times x squared is x to the 4th. X squared times negative 2x is a negative 2x cubed. X squared times negative 4 is a negative 4x squared. Subtract the 2 rows. Here I get 0. Negative 3 minus a negative is going to be a negative x cubed. Negative 2x minus negative 4x is going to be a positive 2x squared. And that's all I have for there. So then I do x squared goes into negative x cubed. That's going to give me a negative x squared, no, negative x times x squared is going to be negative x is going to give me negative x cubed. Negative x times negative 2x is going to give me a positive 2x squared. And negative x times negative 4 is going to give me a positive 4x. Again, subtract your rows. 0, 0. I have nothing to subtract here, so I bring this one, positive 4x, down. And that gives me a 0x. So therefore, my other factor is x squared minus x. Well, obviously, I could, if I was going to go ahead and solve for this, I would factor out the x and leave me with x minus 1 equals 0. Again, apply 0 product property. I would have x equals 0 and x equals 1. Just like I did here. I found the 1, and I originally factored out that x to give me that 0. So there you go, ladies and gentlemen. There's 2 different ways to be able to find the zeros of a function when given an irrational. Thanks.